Welcome back to e-learning course 4, Derivatives and Risk Management. In session 1.2 of lesson 1, we will have a closer look at the simple option strategy that allows us to protect a stock portfolio from downside risk without limiting the upside potential. A corollary of this analysis will be that we can get a formal relationship between put and call options, which is famously known as put-call parity theorem. So let's roll our sleeves up and start with session 1.2. The learning goal of this session is to understand how downside protection can be achieved and to derive put-call parity theorem. Assume that our underlying asset is a stock, which is represented by the 45-degree line in the graph. In this session, we will study a strategy that allows us to gain if the stock price rises, but at the same time provides protection on the downside. The question we have to answer is how can we implement such a strategy? In general, downside protection for a stock investment can be achieved in two different ways. The first approach is based on being long in the stock and long in a put option on the stock. This combination is called protective put. Let's verify why this works by studying the corresponding payoffs. The payoff of a stock is straightforward and corresponds to a 45-degree line, which means the impact of stock price increases and decreases on the payoff are symmetric. Or put it differently, the payoff increases one for one with increases or decreases in the stock price. The next payoff we need to study is related to being long in a put option. Recall that the put option gives the buyer the right but not the obligation to sell the stock at maturity at the exercise price. If an investor buys a put, she might expect that stock prices fall in the future. By being long in a put option, the investor can limit potential losses since she has the right to sell the stock at exercise price K. Finally, the total value of the portfolio consisting of a stock and a put option at expiration is as follows. Whatever happens to the stock price, you are guaranteed a payoff at least equal to the put's option exercise price because the put gives you the right to sell your share for that price. This means your downside risk is limited while potential gains from increasing stock prices are intact. The costs of establishing such a position are the stock price plus the premium for the put option. Previously, we have seen how put options can be used to provide downside protection. The same result can be obtained by combining a long position in a call option and a bank deposit. In order to understand why this makes sense, let us again study the corresponding payoffs. The first diagram in the second row shows the payoff from placing the present value of $175, which equals the exercise price of the call option in a bank deposit. Regardless of what happens to the price of the stock, your bank deposit will pay off $175. Next, the payoff from a call option on the stock with an exercise price of $175 is illustrated. The investor receives a positive payoff if the stock price is larger than the exercise price on the day the call option expires. Note that the investor uses the bank deposit to buy the option for $175 at maturity. When we combine these two positions, we achieve the same payoff as in the first approach above. If the price of the stock falls, your call is worthless, but you still have your $175 bank deposit. Moreover, for every dollar that the stock price rises above the $175, your investment in the call option pays off an extra dollar. In summary, you participate fully in any rise in the price of the stock while being fully protected against any fall. So far, we have learned that downside protection can be achieved by two strategies which yield the same payoff at maturity T. This can be done by being long in a put option and a stock, or by being long in a call option and placing the present value of the exercise price on a bank deposit. Since the two investment strategies give identical results, we just set them equal and arrive at the fundamental relationship for European options, which is called put-call parity theorem. More formal, the value or price of a call C plus the present value of the exercise price K divided by 1 plus R to the T is equal to the stock price S0 plus the value of the put. The beauty of the theorem lies in the fact it allows us to deduce the price of a call option if we know the price of the corresponding put option. In applying the theorem, it is important to note that put-call parity theorem holds only for put options with the same exercise price and expiration date as the call and vice versa. In order to get a deeper understanding of put-call parity theorem, let us look at an example. As you might recall, one of the fundamental principles in financial economics is that if two investments offer identical payoffs, then these investments should sell for the same price. This is what economists call the law of one price. If this law is violated, there exists a potential arbitrage opportunity. Suppose that the price of a 6-month call option with an exercise price of $530 was $36. The annual risk-free interest rate is supposed to be 0.5%, and the price of the stock is $530. Using put-call parity to compute the price of the put implies a value of $34.68. Now suppose the price of the put is $37 instead of $34.68, which implies a violation of put-call parity. Based on this fact, an arbitrage strategy can be built as follows. Short the put option and the stock and take a long position in the call option. This yields a cash flow of $531 since you obtain $530 from the sale of the stock and the price of the put you sell is $1 higher than the price of the call you pay. Invested at the risk-free rate, this sum yields $532.33, which implies a risk-free profit of $2.33. The reason for this is that no matter if your stock price increases or decreases, you obtain the stock for a price of $530. For instance, if the stock price at maturity is larger than the exercise price, you will exercise the call and buy one stock for $530 and thus make a risk-free profit of $2.33. In the other case, when the stock price at maturity is below the exercise price K, your counterparty, the buyer of the put, will exercise the put option and sell you the stock for $530. Again, a profit of $2.33 will be made due to arbitrage. After having carefully studied session 1.2, please start with the review question.